Welcome to today's lesson. Today we're going to be talking about trigonometric. Now we're going to talk about trig identities. Here is the king of all of them. Sine squared theta plus cosine squared theta equals 1. This is the one you have to remember. Now let's derive the other two. If we divide each and every term by cosine squared theta, so I divide this by cosine squared theta by cosine squared theta by cosine squared theta, sine over cosine is tangent squared theta plus cosine over cosine is 1 is equal to 1 over cosine is secant, but we've got a squared, so it's going to be secant squared theta. So we don't have to memorize this, we can derive it from the original by dividing each and every term by cosine. We can also find another identity by dividing each and every term by sine squared theta. If I divide each and every term by sine squared theta, by sine squared theta, by sine squared theta, let's figure out what we have. Sine squared theta over sine squared theta is 1, plus cosine squared theta over sine squared theta, we know that's cotangent squared theta, equals 1 over sine, remember that's cosecant squared theta, or CSC. So now we've got three different identities. Our first one, the king of all identities. Sine squared theta plus cosine squared theta equals 1. Yes, you have to know that. Divide each and every term by cosine squared theta and we get tangent squared theta plus 1 equals secant squared theta. And finally, if we divide each and every term by sine squared theta, we get 1 plus cotangent squared theta equals cosecant squared theta. What I remember is tangent and secants are tied together, and cotangents and cosecants are tied together as well. Double angle identities for cosine. This is how I remember it. What you really have to remember is this, but I go through the progression. I know that earlier in high school I learned cosine, one angle plus another is cosine, cosine, sine, sine, and that's cosine of the first times cosine of the second. This is a plus. My sign in the middle goes to minus sine of the first, sine of the second. I know that. I learned that in my sophomore year in high school. I should have. Cosine A plus B is cosine, cosine, sine, sine, A, B, A, B. Whatever is there is the opposite SIGN in the middle there. Well, if I know that, then I can think about cosine theta plus theta would be cosine, cosine, sine, sine. If there's a plus there, it's a minus in the middle. And what's this? It's a theta. 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 Both the A and B's are theta. So I can simplify that to theta plus theta is 2 theta. Cosine theta times cosine theta is cosine squared theta. Sine theta times sine theta is sine squared theta. If you don't want to remember any of that, you can always just jump to this. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. This is important to remember. Will it be on your formula package? Absolutely. But if you're looking at that formula package to get this, you're going to be wasting time. Let's see if you can follow what I'm doing here. We just established this, that cosine 2 theta is equal to cosine squared theta minus sine squared theta. Well, we learned earlier that sine squared theta plus cosine squared theta equals 1. That's our king of all identities that we have to know. If that's the case, I could subtract sine squared theta from both sides and wind up with this expression here. Cosine squared theta is equal to 1 minus sine squared theta. Well, if that's the case, I go back to my original equation here and I see, well, cosine squared theta is there. I could substitute this value in for cosine squared theta. When I do that substitution, I wind up with cosine 2 theta. Instead of cosine squared theta, I have written 1 minus sine squared theta. Because they are equal, I can substitute, and then minus sine squared theta comes along for the ride. If that's the case, minus 1 sine squared theta minus 1 sine squared theta gives me 2 sine squared theta, a negative 2 sine squared theta. And I wind up with cosine 2 theta is equal to 1 minus 2 sine squared theta. This is another identity that we should know. Similarly, I start again with my one I just learned, my double angle I just learned, and I again write the king of all identities, sine squared theta plus cosine squared theta equals 1. This time I solve for sine squared theta by subtracting cosine squared theta from both sides, and I wind up with this expression. Well, here it is in my original double angle identity, and I'm going to, instead of having sine squared theta, I'm going to substitute 1 minus cosine squared theta in there. giving me an expression cosine 2 theta equals cosine squared theta minus, instead of sine squared theta, I'm going to write 1 minus cosine squared theta. My negative will distribute out, and when that does, I'll have positive cosine squared theta plus cosine squared theta gives me 2 cosine squared theta. Negative times positive gives me a negative 1. So here's a third identity we should know. Here's our last double angle identity. Remember we started with this before. Cosine A plus B is cosine, cosine, sine, sine, AB, AB. And whatever's there is plus, goes to minus there. I remember that one, and then I changed it to give me the sine double angle. I know that this remains the same, and this remains the same, and the first half of each one I have to change, from cosine to sine, and from sine to cosine. And I also know that if it's a plus here, it goes to plus there. So what I do is I remember the cosine one, and then change it slightly. Well, if you can make that jump, we can say, well, instead of alpha and beta, or two different angles, what if the angles were the same? That would be sine A would be theta, cosine theta, plus cosine theta, sine theta, because my A's and B's are the same. Well, sine theta, cosine theta, plus sine theta, cosine theta is really just two of these. 2 cosine theta, sine theta. I can switch back and forth to sine and cosine because they're just multiplying. So here is my last identity that I must know. Sine 2 theta is equal to 2 cosine theta, sine theta. Here is a summary of our double angle identities. You need to know these. Cosine 2 theta equals cosine squared theta minus sine squared theta. Cosine 2 theta equals 2 cosine squared theta minus 1. Cosine 2 theta equals 1 minus 2 sine squared theta. And finally, sine 2 theta equals 2 cosine theta sine theta. Will these be given in your formula package? Again, yes, but you'll be wasting time if you have to search for them. And the second part is, you have to be able to identify these in a problem. So recognition of these and memorization of these is super important. Here's an example using a trig identity. It says to simplify cosine theta plus tangent theta sine theta. There's multiplication in there. I don't know what to do, so I will just start playing around with this. Well, I know tangent theta is really sine over cosine. And then I can multiply sine times sine and get sine squared theta. So I wind up quickly changing the expression to this. Well, again, I just am going to play around with this. I know sine squared theta is equal to 1 minus cosine squared theta from my king of all identities. At this point, I can think about if I have A plus B divided by C, I have to divide the C into both of the terms. I get AC plus B over C. Well, if that's the case, I can divide cosine into 1 and cosine into cosine squared, and I'll get this is equal to cosine theta, my original cosine theta there. 1 over cosine theta is really secant theta. Negative cosine squared theta over cosine, cosine squared over cosine is going they'll cancel off, and we'll be left with minus cosine theta. What's cosine theta minus cosine theta? These will cancel off, and we're left with secant theta. So yes, I have been able to simplify. Let's do some examples with trig identities. If cosine equals negative 3 over 5 in the third quadrant, where theta is between pi and 3 pi over 2, well, there's my theta. And my cosine is adjacent over hypotenuse, so I know to put a negative 3 over 5 there. Find sine of theta. Well, I know I can relate these two by sine squared theta plus cosine squared theta equals 1. There's the king of all of my identities. So sine theta is equal to 1 minus cosine squared theta, and I'll take the square root of that. I move the cosine squared theta over, and I take the square root. So sine theta is equal to 1 minus negative 3 over 5 squared, and I'll take the square root. I'll have plus or minus the square root. So sine theta is equal to, when I work this math out, I get plus or minus 4 over 5. Well, in the third quadrant, my y-coordinate, or my sine, is negative. I have to go down 4. So I'm going to take the negative root there. This would allow me also, so there is my answer to this problem. In part B, I could find tangent theta. Well, what is tangent? Tangent is sine over cosine, so that would be negative 4 over 5 divided by, and my cosine here was negative 3 over 5. If I multiply by the reciprocal, I'll have negative 4 over 5 times negative 5 over 3, which will give me positive 4 over 3 for my tangent.